Hi, my name is Ninoshka Singh and I'm a Master's of Engineering student in the Electrical and Computer Engineering department. And today I want to just talk to you a little bit about my research and my project that I did for my M.Eng thesis. What I have here with me, as you can see I'm actually wearing it, is called JointSafe. And JointSafe is a wearable sensor system, a wireless wearable sensor system, whose application is for patient rehabilitation. The idea behind the project was 3 years ago when I was a bachelor at Cornell, and I was in Professor Bruce Land's ECE 476 Embedded Systems class. The project started off as something called HipSafe, and the idea was the same thing, that we wanted to basically create a wearable sensor system that could measure motion of an injured hip for patients that have undergone hip replacement surgery. So that was 3 years ago. I decided to come back to Cornell and I wanted to continue further building the system and make it actually wireless, which has kind of been one of the key focuses of this year. So that project I worked on with another person as well, Ninoshka Singh, and Natasha has worked with me throughout this past semester on developing actually this Android application that I'll talk a little bit about. So a little bit of an overview of the JointSafe system. So JointSafe still measures only hip motion like HipSafe did, but the idea is that JointSafe's development will continue and will eventually be extended to other application domains. The current system measures hip motion of an injured leg. There's 3 sensor nodes, one mounted on the knee, one mounted on the thigh, and one on the chest. And the idea is the system measures motion restrictions for a patient that has to follow these during their rehabilitation period after hip replacement surgery. If the patient doesn't follow certain motion restrictions, like what we call pigeon toe movement, which is knee rotation, they could actually dislocate their hip. So the system monitors that motion by calculating roll and pitch angles about the knee, the thigh, and the chest. And then it uses that information to alert the patient when they're about to violate one of those restrictions. The tablet over here actually serves as our central monitoring device. So the Android tablet actually receives data wirelessly from each of the sensor nodes, and then it monitors that roll and pitch angle information, and when the patient is about to violate one of those motion restrictions, the tablet would actually send an alert feedback to the patient via vibration along the leg. So there's 2 key things that the system measures right now. One of them is called hip flexion, and hip flexion is essentially measuring the angle between the thigh and the chest. If the patient actually bends less than 90 degrees between these 2 body segments, again, they could dislocate their hip. So bringing up my thigh to my chest would actually be violating the motion if it was an acute angle, less than 90 degrees. If I were sitting down and I leaned forward like this, and I bent, again, less than 90 degrees, that's also part of the hip flexion motion restriction that we monitor. The second key restriction, as I mentioned earlier, it's the kind of layman's term for it is pigeon toe movement, but it's actually internal knee rotation. So moving and rotating my knee so that my toes are rotating towards the center line of my body, that actually could, again, dislocate the hip for the patient. So we monitor that motion and we provide the vibration feedback if the patient violates that. Going back to the application, so the application is running on a Motorola Xoom tablet. The idea behind this is we figured that most people, own a smartphone today, so their central and primary device around them is going to always be either a smartphone or could be a tablet, but for the purpose of the demo, we wanted to use a big screen, so we chose a tablet. But most people carry around a smartphone, so instead of having them wear an additional unit with an additional processing device on them, we thought it would be more convenient and more practical to have the smart device actually receive the data, and then the patient can view that data. They could also see a visual alert feedback on the screen that would appear to them, which is more practical. For now, our particular application shows a few different things. It shows you, for sort of development purposes right now, the roll and pitch angle information for each of our 3 sensor nodes on this left pane here. On the right pane here, it actually does show a real-time graph that plots the angle versus time for hip flexion, which is also very useful for development and debugging. And it also showcases that the system is real time. So it's processing this information in real time, and it's able to provide the feedback in real time. And then it also gives you the ability to connect and disconnect via Bluetooth communication from all the sensor nodes. So this is the current iteration of our application, but in the future it will be revamped into a more sort of user-friendly and consumer-oriented application.